Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at grade 11 as well as 12 quadratic functions, okay? Yes, normally referred to as a parabola, okay? Yes, so a parabola has a standard of y is equal to a into x plus p squared plus q, right? So we know from grade 10 that we know our parabola was y is equal to ax squared plus q only, okay? For an example where we had something like y is equal to x squared minus 4, okay? Actually, the original it is this, okay, plus, let me say plus 4, where we actually, let me draw y is equal to x squared. Y is equal to x squared, it is just this part, okay? This is what we learned in grade 10, just this part. Y positive, just this. I'm going to explain the shape in a moment. Okay, but now we also had maybe minus 4, where we were shifting downwards. Okay, so this is what we refer to as the vertical shift. Okay, this was the vertical. Let me minimize this pen. This was the vertical shift here. Vertical shift, meaning it can only go upwards or downwards. Okay, so after doing that, if it is minus 4, it means now it will cut at negative 4 somewhere here. Then it will do the very same thing, but now can you see it is now different because now it is minus 4. If it was plus 4, it was going to come here. Okay, but now in grade 11 we learn how to shift towards the left. Okay, so we will learn to shift towards the left. So the normal y is equal to a x squared. Okay, let me write it here. Y is equal to a x squared plus q, where now, sorry, q, it is our vertical shift. We are saying, okay, in grade 11, we need to introduce now what we refer to as horizontal shift. Okay, so how is the horizontal shift? Okay, so we're going to say now, for us to introduce horizontal shift, we need to say y is equal to a into horizontal shift. It will affect the x, so it's going to be x plus or minus p squared plus q, where now our q is still the what? The vertical shift. But now this part plus p plus or minus p, it is now our what? Horizontal what? Horizontal shift. Okay, if you have watched one of my previous playlist under grade 11 functions, grade 11, 12 functions, hyperbola, exponential, and all of that, you will know what we refer to as plus or minus p. Okay, you'd know that if the value of p, okay, let me erase this one, just say q. You know that if the value of q is greater than, sorry, if the value of p is greater than 0, meaning if, okay, let me say if p, yeah, is greater than 0, meaning p is positive, it's going to shift towards the left. Okay, it's going to shift towards the left. We normally want to say if it is positive, okay, plus it will go to the right. Okay, but in this case, that's not the case. Why? Because if I take x plus 4, then I equate that to 0. Yes, it is positive 4 here, which we might want to say it is towards the right. But when we say x, it is equal to, can you see now it is equal to what? Negative 4. The negative 4 is the one that tells us, okay, we are actually moving towards the left. Hence now, I'm saying if p is greater than 0, or p is positive, it is moving towards the left. What do I mean by that? It means if I have x plus p, okay, I'm going to equate that to 0, then it will give me x, it is equal to negative p. Therefore, x is equal to negative p tells me, the negative sign tells me that I'm going towards the left. Okay, then if p is less than 0, meaning p is negative, it means it is moving towards the right. How do I know that? Let x minus p equal to 0. Can you see my p is negative? Then when I solve this, x it will be equal to what? P. Can you see now my p is positive? Then it tells me that p is going towards the right. So that's what you need to know in terms of the value of p. Okay, this is what you need to know in terms of the value of p. Let me quickly copy that. Okay. Okay. And move it somewhere here where it's gonna not where it's not going to disturb us. Okay. Yes, we're still moving it somewhere here. Cool. So this is a very, very interesting thing that you might be in a position of wanting to understand. This is what you want to understand so that you do not get confused during exam time. Okay. Yes. So now let's move on to orientation. Okay. Or rather, I prefer it to as the shape. So now we can see that in our equation we have the value of a here. So basically what the value of a says, it tells us about the orientation. I normally say a tells us about the shape. Okay. So if a is greater than 0, it is happy. Okay, greater than 0, remember, means positive. It means now it is a what? It is gonna form us a what? A happy face. Okay. If you are positive, it means you are happy. Okay. But if the value of a it is less than 0, which is negative, it means your energy is negative. So it means now you are not happy. It means you are sad. In that particular case, they're off. Okay. So this is what you want to know in terms of when you are going to draw. Okay. Okay. If my a is greater than 0, let's say maybe I have y is equal to 2 into x plus p plus q. Then I can't forget the squared here. I don't know how I forgot that squared. Oh, okay. Here, can you see that my a is greater than 0? It means whatever shape that I'm gonna draw is gonna be looking like this. Value of is gonna face up. If it face in an opposite direction, you know that something is wrong. Okay, yes. Now, okay, never mind this part. When actually it says when the value of a becomes uh more greater. Okay. So the greater the value of a, the magnitude of a, okay, let me not use the absolute value. The magnitude of a, if it becomes more, actually, let me not say greater than 0. If the value of a increases, okay, it causes our graph to become narrower. Okay. So can you see it causes our graph to become narrower, whereas what? As a increases. Okay. Now, in the graph that we might draw a graph like this. Okay. Remember, there is what we refer to as the turning point. Turning point. Remember, let's take a quick recap. Let's take a quick recap. Okay. A quick recap. In grade 10. Okay. In grade 10, you had this formula. Y it is equal to x squared plus, okay, let me say ax squared plus q. Okay. Your q in grade 10 was your turning point. Okay, what do I mean by that? It means if you had something like y it is equal to x squared minus 4, remember your graph is going to look something like this. It's going to look something like this. The value of a is positive here. So it means if the value of a is positive, can you see the value of a here? It is 1. The value of a is positive, it's going to be a happy face like that. Okay, let me redraw that. Okay. So, but now, can you see it is our graph is shifted downwards? Remember, it is also a what? A horizontal, so vertical shift. Vertical shift. So it has shifted downwards by 4 units. So it means it will have a value here at -4. And then remember, our graph originally looked like this. This is the original graph. Let me redraw that. The original graph, it is this. It is this, right? But now, since well, it is shifted downwards 4 units, it's gonna move from -4 like that, yo, way, and like that, okay, and like that. Can you see now that your turning point in this case, remember I said this is the turning point, okay? If this is the turning point, it means the coordinates of your turning point, the coordinates of your turning point is going to be x here, it is how much? X, it is 0, and then y, it is equal to -4, okay? So this is what we learned in grade 10, that your turning point is going to be 0 and the value of q. But now things are going to change, okay? Things are changing because now we are no longer shifting horizontally only. We are also shifting what? Vertically. So your graph will not always be like this. Okay. Okay. Or like this. Okay. Sometimes your graph, you will find it. Now that you're going to be learning grade 11 thing is, your graph might sometimes look like this. Can you see now our turning point? Here is it. Can you see now our turning point has shifted? So we cannot say the turning point, it is the value of q, because the value of q was our y-intercept. In this case, it is no longer our y-intercept. It is now something here. So hence now we have to change what we knew and now learn new things. Okay? How do I find the turning point? Basically, this formula here that you are given, that y is equal to a into x minus p, or let me say plus p squared plus q. It is a turning point formula. I refer to it as a turning point formula. Why? Because it gives you the coordinates of the turning point. What do you mean by that? Now, it means now your turning point, if you are given this formula, it's going to be negative p and q. Why am I saying negative p? Remember, p here, if it is positive, on the graph, it's going to be negative. How do I know? X plus p, when I equate that to 0, is going to be x is equal to negative p. Okay? Yes. Let's have an example so that this makes sense. Let's have y is equal to 2x minus 4 squared plus 3. What is my turning point? My turning point is going to be x minus 4 is equal to 0. Therefore, x is equal to what? 4. Also, it means now it's going to be 4 and what? And 3. Okay, which is the same as saying it is negative p and q. What is negative p? What is p? I'm going to say negative. What is p? P, if I check it here, it is negative 4. Then what is my p? P, I just write it as it is. Then can you see still the same? Negative, negative, give me positive, and then like that. So it's fine. You can say equate that to 0 and you'll be fine. So this is what you basically mean when you say now our turning point, it is basically found from these coordinates. Okay, only if you are given this in a turning point what formula. Okay, we have two forms. I mean, this, it is y is equal to ax squared plus bx plus c. This is also another standard. This is the standard form, okay, of a parabola, which we will look at later on. Okay, and if you are given this standard form, there is a formula for finding a turning point, which is x is equal to negative b divided by 2a. But now let's look at this one where we are given the turning point formula. Okay, yes. So I'm saying if you want a turning point, it's going to be this coordinate, negative of this coordinate, then comma that one. Okay, yes. Now let's look at that. Can you see now? You know that if your graph is like this, okay, whatever, let's say, okay, we know that our graph basically was gonna be okay. In grade 10, what we learned, I'm sorry for bad drawing, I just want to explain something. We know that this turning point here, if I were to cut this into two, okay, into two equal halves at exactly the turning point, I will have what I refer to as the axis of symmetry. Okay, my axis of symmetry cuts this such that if I'm having positive 2 here, on this side I'm having negative 2. Remember, it is not drawn to scale. If I'm having 4 here, I'm going to have what? Negative 4. Okay, so this is what we refer to as the axis of symmetry. It tells us exactly how much it is in the middle. Like here. And also, you know that if you are having, what's this? Okay. graph like that, and then you are given that here maybe the coordinate is -1 and here it is -1. How do you find the axis of symmetry? Remember, the axis of symmetry, it is exactly in the middle, okay, in the middle of the two x coordinate, the x1, negative x1 and positive x1. So it's going to be the axis of symmetry here, which is the same as the turning point. Okay, the x coordinate of the turning point is going to be what? X1 plus x2 divided by 2, which is become what? -1 plus 1 divided by 2, which gives us what? 0. And can you see that it is 0 here? Yes. So I want you to take that into account, okay? Even if our graph were to shift and be like this, and then they now say to you, this value here, it is 3, okay? 3, and this value here, it is 1. Okay, let me erase this. It's fine. And you are told this is 3 and this is 1 here. Remember, axis of symmetry is going to be something that runs from the middle here, okay? So how do you find the axis of symmetry? So you will say now, axis of symmetry, it is what? Here, which is the x-coordinate of the turning point. Remember, this is P, negative P and Q. So the x-coordinate of the turning point, how can I find it? I'm going to say, sorry, it is 1 plus 3 divided by 2. Then I get the middle as how much? As 2. So it tells me that the coordinate here in the middle, it is how much? It is 2. So let's look at that in more depth. Okay? In more depth. The axis of symmetry. Okay? I unfortunately cannot zoom any further. So they say to us, the axis of symmetry is the vertical line passing through the turning point, okay? Then the equation of the axis of symmetry is x is equal to -p, what I explained here. Remember, it is x is equal to the negative coordinate, okay? So now, this line, it is exactly equal to the value of x. Actually, in simple terms, is that the equation of this line, it is x is equal to the x coordinate of the turning point. Okay? Yes. That's basically that. Okay? Now let's look at the range and the domain. Okay? Remember, the domain, it is everything. Let's enlarge this sketch. Okay, let's have our original sketch like this from grade 10. This is just a revision from grade 10. I want us to remember something. Remember, if I look at the domain is all element of x. Okay, all element of x. So when I look at the domain, all element of x, I'm going to look from the left to right. Remember, when I have, if this is my x, sorry, if this is my x-axis and this is my y-axis, I'm going to look at the x-axis and look at all the values of x, okay, on my domain. So when I check here, I normally use my ruler for this case. I used my ruler when I was still learning this in grade 10. I was like, okay, where does this value of x start? From the left, okay? Where do I find my x from the left? Here it is, okay? Can you see here? The value here, it is what? It is negative infinity. So here I have negative infinity. And my graph, it is going where? And as I move, and I reach this point. This point here, where there is an arrow, it tells me it goes to what? To positive infinity. So it tells me that my domain for this graph, it is x is an element of from negative infinity to infinity. Or someone might say x is an element of what? Of all real numbers. Okay, yes. So all the parabolas, okay, all the parabolas are going to have this shape. So the domain of a parabola, it is always x is an element of negative infinity to infinity, which is basically the same as x is an element of what? Of real numbers. So let's look at this one. There are no restriction on the domain of parabola. Thus, x is an element of real numbers. Exactly what I've just explained it of. Let's look at the range. The range is all values of y, okay? I do not want you to cram this part. We will come to it, but I want you to understand it, okay? All values of y. It is the what? The range. All values of y, starting from a negative y to positive y, or starting from bottom to top. Okay. When I take my ruler and start from bottom to top, let's see what I have. When I come here, I want to see where my graph starts. Okay. I come here, I come here. Can you see there's no graph, there's no graph. But immediately when I reach this point where y is exactly equal to 0, I have my graph again. So I can see that, okay, here, uh, at this point here, let me do this. At this point here, uh, y it is equal to 0 at this point again. Therefore, I'm moving, okay? I'm moving along with my graph in the vertical. I move, I move, I move. Can you see now my graph is going to what? It's gonna go infinitely up until it reaches whatever that value. So it starts from 0 and goes to what? To infinity, both of them. Okay. You are not saying it is going from negative to negative infinity and the one is going to infinity. No, we are looking at the values of y. Okay, the values of y are going to what? To positive infinity. So it means for this one, the range is gonna be so range, it is y is an element of, where does it start? It starts at here at y is equal to 0, and our graph is equal to 0 there. So I'm gonna include what? 0. Okay. If my graph touches that point, I'm going to include it again. Therefore, it goes toward to infinity. Infinity, we do not include it because it does not touch our graph. If I'm doing this, it includes, okay, or when I do this, it is excluded, okay? Yes. But I have to include 0. Why? Because 0, 0 in this case, it is there on my graph. It touches my graph, okay? What if we have this shape thereof instead of the one that we are having? Uh, what if we are having this shape? Okay, let's say here it is just uh 2. Okay, remember, how do I check my domain? I start from the bottom. Okay, the y values, the negative y values, the bottom. Can you see when I start here, there's no graph, but here there is a graph, but those values are how much? Can you see? If I see arrows, I know that is what? Infinity. But in infinity, in which direction? In the negative direction. So it means my graph starts from what? From negative infinity. Let me use a different column. That's from negative infinity. And then as I move up like that, where does my graph ends? My graph ends here where y is equal to what? 2. So my graph ends where y is equal to 2. If I interpret this in terms of my range, I'm going to say my range, it is starting where? Where does it start? Can you see it starts from negative infinity? I do not include negative infinity, but where does it end? It ends at 2, and I have to include 2 because it touches that point thereof. Okay, yes. Now let's look at the basic theory that they are explaining to us. They say if a is greater than 0, okay, I feel like this highlighter is too much. They say if a is greater than sorry. If a is greater than 0, the range is all y values greater than or equal to blah, 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 blah. If a is greater than 0, here it is, okay? Can you see? Therefore, it has a minimum value. Can you see that? Here it has a minimum value, okay? Then it goes to a maximum value, which we do not know. So, but here it is the minimum value here. 0 is less than infinite. But here, when we are having this is the what? It has a what? A maximum, because this value is a maximum like this. 2 is greater than negative infinity. Okay, so how do we, if these are the coordinates, okay, if it starts here and goes up there, when we look at our range is going to be what? Starts from Q and goes to what? As we go up, it goes to what? To infinity there. So it can be y is an element of Q to infinity, like we wrote here. Q in this case, it was 0 to what? To infinity. Okay, you can also write it like when y, okay, can you see that we find our graph when y is greater than 0, from 0 to above? So you can say y is greater or equal to what? To 0. Here, you will say when we find our graph from 2 going downwards. So it means when the values of y are less than 2. So it means when the values of y are less or equal to what? To 2. Okay, another notation is this one. Preferably, I use this because I understand it more much. Actually, in grade 10 and 11, and yeah, I think in grade 10, I learned this one and understood it before I can go to this one. Because this one, you can make mistakes easily. Okay, yes. Then when value of a is less than 0, where we have our maximum value, we're going to say, okay, our graph starts from where? From negative infinity. And as we go up with our graph, it goes to what? It reaches this point. So it starts here at negative infinity. As I go up, it ends at what? At the value of q. So I'm going to say it started at negative infinity and ended at what? At the value of q, like that. So here we can say it started at negative infinity and went to q. Or you can say I find my graph from the value of q going downwards. So it means from the value of q, okay, moving downwards in the negative direction. So when y is less or equal, because here if it is this is q, when the value becomes less, then that's where I also find other portion of my graph. So I'm going to say y is less than 5. Preferably I use this one. It starts from what? Can I see here? These are what? Negative infinity, and it ends at where? At q. And I know q, I should include it. So that's basically that from a domain range. Okay, you should know the domain range for all the functions that you come across. Now let's look at sketching the graph of a function. Okay, now let's say we are given, here is our equation, and then you're required to sketch that. Okay, mostly in grade 11 you are required to know how to interpret it. Okay, mostly in grade 11. In grade 10 years you can sketch and all of that, but in grade 11 and 12 you know how to apply it. You have to know how to apply parabola, and they won't give you just a parabola alone. They will give you a parabola with maybe some straight line. Okay, but we need to start knowing the fundamentals of a parabola first. Okay, yes, if you're doing grade 10 you can use calculus, especially for finding minimum value, maximum value, the distance, as well as what's this, yeah, as well as all of those. We will see them. Okay, now give an example. F of x, or let me try to zoom that. Okay, given f of x is equal to negative 2 into x plus 1 squared plus 8. So we are given this in what? In turning point formula. Okay, remember this is the turning point what? Formula. How do I know? I see by x plus 1 and squared, blah 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 blah. So number A says to me, sketch the graph. Okay, so these are the important things you need for you to draw the graph. Okay, I'm going to teach you. These are the things that you're going to need to draw a graph for a parabola. Okay, the first one, it is you knowing how to calculate the x-intercept. Okay, as well as what? Y-intercept. We know that from all the functions. Okay, this is the first one. The second one, you need to know how to find the turning point. Okay, and then you are done. Okay, yes. First thing first, before I look at something, I interpret. How is the value of A? The value of A is less than 0. It is negative. Again, therefore, if it is negative, I'm expecting a shape that is sad. This is what I'm expecting. Okay, I'm expecting my graph to have this shape. Okay. Then this will be my y-intercept. I forgot to mention this. This is my y-intercept. Okay, on this formula here, this will be my y-intercept. Okay, this is my y-intercept. Okay, actually, no, it's not. It's fine. It's not. It's not on this graph. Cool. We'll just find the x and y intercept. Let's do that. Let's look at the x and y intercept first. How do I find the x intercept? Okay, let me start with the x intercept. This is me before drawing. For x intercept, I let what? y equal to 0. So then I'm going to have 0, it is equal to negative 2 into x plus 1. So all squared plus 8. And then when I take this 8 to the other side, it's going to be negative 8. It is equal to negative 2 into x plus 1 all squared. And then I have something like 4. It is equal to x plus 1 squared. And then I want you to take note of something. I squared is. But remember, when you square something, okay, when you square something, remember it is plus or minus what? 2. Then I have what? X plus 1. So this tells me that x plus 1 can equal to positive 2, or x plus 1 can equal to what? Negative 2. Therefore, x it is equal to what? 1, or x is equal to what? Negative 3. So these are my x intercept. If someone knows that they are going to forget plus or minus, you can manipulate from this point. Let's have another step. From this point, another alternative method, you can say 0 is equal to negative 2 into, and simplify this and get x squared plus 2x plus 1 plus 8. And then simplify thereof, you'll get negative 2x squared minus 4x minus 2 plus 8, which is basically the same as plus 6. And then when I take out the highest common factor of negative 2, when I divide by everything by negative 2, I get x squared. When I divide by negative 2, get x squared plus 2x minus 3. And then I can get factors of 3. Still, remember, it's still equal to 0. Then I can get factors of 3 such that when I subtract, they give me 2. It is x minus 3, but it should be positive, and x minus 1 is equal to 0. Therefore, x is equal to negative 3, or x it is equal to 1. So whichever way you prefer, it's fine. Okay, yes. As long as it gives you the same answer. But here, when you square root, you need to remember that this is plus or minus. Then let's look at the y-intercept somewhere here. Okay, it's fine. I want us to draw on this side. Let's look at the y-intercept. The y-intercept, what do I do? Y-intercept, I let what? Let x equal to 0. Then I have y is equal to negative 2. I get negative 2 into 0 plus 1 squared plus 8. Then, is it plus 1? Yes, plus 8. Then how much do I get? I get negative 2 plus, I get 6. Okay? Yes. I like to write this in terms of coordinates and say my coordinates are therefore 1 and 0 here, negative 3 and 0. Remember, if x is 1, y was 0, and x is negative 3, y is equal to 0. Here I'll say if x was 0, can you see? My y was 6. Then the last part is me determining the turning point, which is the easiest. The turning point, how do I find it? I say my coordinate is y is equal to negative 2 into x plus 1 squared plus 8. Remember what my turning point is here. Okay, remember my turning point, it is going to be negative p and q. Okay, or what you can do is say x plus 1 is equal to 0, and then you get that x it is equal to what? Negative 1. Therefore, your turning point is going to be what? Negative 1 and 8. Just leave it as it is, like that. Okay. But if I just know, if I want my turning point, if this is positive here, if my x is positive here, when it goes to the graph or to my turning point, it changes the sign. It becomes minus 1 and 8. But in case you forgot, or you do not like to memorize, just understand this. Okay, yes. So now we are in a position of sketching the off. Okay, we are in a position of doing what? Of sketching. So I'm going to say, let this be our sketch. Okay. Remember, it's going to be a set face, okay? Let me try to straighten that. Yes. Then let me label that. Okay, can I take this thing of mine, maybe here. Okay, yes. It's not necessarily straight, but yeah, X, my Y. I do not like doing 1, 2, 3, 4, 5. No, 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 no. If you know from the previous videos where I've been doing this for hyperbolic function, what's this exponential function, I do not do the scaling. What I do is I check what are my x-intercept. My x-intercept, it is 1 and 0. 1 and 0. 1 and 0 might be somewhere here. Okay. I say this is 1 and 0 and just 1. Okay. This is me labeling this is 1. And then, okay, let me just use the same color. This is 1. And then I have -3 and 0. -3 and 0 might be somewhere here. -3 and 0. And then I look at my y-intercept. My y-intercept, it is how much? My y-intercept, it is, can you see? It is 6, 0 and 6. 0 and 6 might be somewhere here. 0 and 6. Okay. And then where is my turning point? My turning point, it is -1 and 8. Where is -1? -1 might be somewhere here, I guess. And then I need to go all the way from -1 up to, okay, I want to show you this. Up to 8 somewhere here, I guess. Then maybe this might be 8 somewhere here. So it means I might have a coordinate somewhere here. Something like that. I guess. So now can I join? Do you remember this is -1 and 8? This is my turning point. Now, can I join? How do I join? I need to know what shape am I expecting, the happy or the sad one. Remember, we have already said that the face should be sad like that. So it means I need to join here from this point to that point like that. Try to make it as smooth as possible. And then, remember here, it's going to just do a little curve at my y-intercept and then move downwards like that. It's going to cut there. Can you see? Can you see? Me knowing the shape, it tells me, oh, I know very well where I need to go. I get. So can you see all the important information that this is -3, this is +1, this is 1 and 8, this is 6. Can you see now? It makes I have won because now all my points that are important, I have written them out. 0 and -6, 1 and 0, and -1 and 3. Can you see that? How easy it is? Easy, right? Then let us erase this and now be in a position of interpreting, or rather answering the questions that are going to be followed after this. Okay. This will be, okay. So this is number A. We have completed number A. Let's look at number B. Let's answer number B. This is our sketch, not necessarily cute or beautiful, but yeah, you can see. Then number B, what is the equation of the axis of symmetry of X? So of F. Remember the axis of symmetry passes where? Passes exactly at the turning point. So what is the coordinate of the X coordinate thereof? Therefore, what is the coordinate of X? Therefore, we're going to just say X, it is equal to -1. Okay, this is the axis of symmetry that has an equation that X, it is equal to -1. But if it was a line like this, since when it cuts at Y, we're going to say Y is equal to something. But this one cuts also at X, so we're going to say X is equal to that something. That value there, it is how much? It is -1. C, write down the domain of F. This shape, it is what? It is a parabola. And for parabola, X is an element of real numbers, or X is an element from -infinity to what? To infinity. Again, how do I know? If I take my ruler from here, it starts at -infinity, and as I go towards the right, it ends at where? At -infinity. So yes. Number D, write down the range. Remember the range of F, I like to start from the minimum. The minimum, which one do I come across first? Which value do I come across first? I get -infinity, okay? I'm going to say Y is an element of, I get -infinity. And then as I go up, my graph ends at what? Ends at Y is equal to what? 8. Okay? So I'm going to say 8. Is 8 included on my graph? Yes, I have that point on my graph. It's like this. Or someone might say, my graph needs to start at 8, going where? Going down. Okay? Going downwards. How do I denote that? My graph starts from 8 going downwards. like that. So that is basically that. And then let's look at another one happy of us sketching. Okay. Okay. Remember, after sketching, we need to indicate, oh, this is the graph of f. Then let's look at the let's look at the other example where now we look at another sketching. Okay. So we say here x minus 1 squared plus 2. Then before I move, can you see that my a here it is 1? So a it is greater than 0. I'm expecting a what? A happy face. Okay. Then let's sketch. What do I need for me to sketch? I need the x-intercept. Okay. Let's sketch. The x-intercept, for x-intercept, I let y equal to 0, and then I'm gonna get 0, it is equal to x minus 1 squared plus 2. I prefer to simplify this normally. I get x squared plus not minus 2x plus plus what? Plus, okay, plus 1 plus 2, and then I will have 0, it is equal to x squared minus 2x plus 3. Remember, this was that, then plus 3. And then can I simplify the values of 3 such that when I add them, they give me 2? Do I have this? Can I simplify this? There's no simplifying this again. So can you see that there are no factors of 3 such that when I add them, they give me negative 2 or 2? Okay. Therefore, since well, this is not possible, you do not say, okay, you can say no solution. What does no solution mean? It means, therefore, there are no x interward intercepts. Okay. Unfortunately, for us, there are no x-intercept. It means our graph, it is going to float this way, just like maybe something like this or something like that. But it does not touch your x-axis like that. Okay. Because there are no x-intercept. Can you see? We cannot solve this one. Then I look at the for y-intercept. I'm going to let x it is equal to 0. Then I'm going to have y is equal to 0 plus 1. Oh, it is minus 1 in this case. Yes. Squared plus 2. And then you get that your y is equal to something like 3. Again, therefore, in terms of coordinates, when x was 0, y was 3. This is a very, very important point. And then let's look at the turning point. The turning point, if I'm given y is equal to x minus 1 squared plus 2. Remember, if I want my turning point coordinate, it's going to be what? Sorry. Turning point's coordinate is going to be negative of p and q, which is basically what? I take this, but when I write it, I'm going to write it a negative of it, or which with changed sign, which is 1, and then what? 2. So this is my turning point. Very beautiful coordinate thereof. Let me try to plot that. Well, let me try to plot that in a graph. When I try to plot that in a graph, I'm going to have my y and my x-axis like that. Okay, not necessarily drawn into scale. Y, x, and y. And then x-intercept I do not have. Let's look at my y-intercept. My y-intercept, it is 3. So somewhere here at 3, it's too much. 3 maybe. And then my turning point, it is 1 and 2. 1, maybe 1 might be here, and then 2 might be somewhere here. Can we see that? Yes. So how do you sketch this if you are having this? Remember, this is going to be 1 and 2. Okay, if you're having these 2 points, if you do not know how your shape will be like, then you are doomed. But remember, a it is equal to 1. Okay, therefore a is greater than 0, meaning it is a heap. So it means I need to join this point from wherever. make this happy. Can you see? Beautiful. Beautiful. Right? This is what we expected to draw. And then let's answer number B. Number B says to us, what is the range of the graph? Remember the range, I start from the minimum value. Where's my graph? I do not find my graph. When I go up, up. The value of y where I start finding my graph, it is here when y is equal to 2 again. So I'm going to say y is an element of, I start at 2 and then I end where at infinity. Or someone might say it is from y, it is equal to 2 all the way up. So someone might say it is from y is equal to y is greater or equal to what? To 2, like that. Okay, now let's determine the equation. Remember, we were given this part now, and now we are determining the what? The equation. Okay, I want you to remember this. If I have y is equal to a into x minus 1 plus 4, the turning point will be the opposite of this, which is 1 and then 4. Okay, so it means now if I'm given the turning point on my graph as 1 and negative 4, it means when I go to my graph, I know it's going to be x. This is positive. It means on my equation is going to be negative, then plus 4. Don't forget the squared. Okay. Makes sense? Let's look at that. Let's look at that. Number A, let's find the equation of this one. Okay, now we are given the turning point. Okay, so if you are having the turning point, I'm going to look at the standard form of A, it is equal to x minus p, or x plus p squared plus 2. And y, it is equal to A into the first thing first, I start with it is my turning point. Okay, x. Can you see here it is negative 2 and negative 1. So remember this negative 2 here. On the graph is going to be what? It's going to be positive 2 squared, then minus 1. This one we write it exactly as it is. Okay. Then am I done? No. Why? Because I need to find the value of A. Again, the value of A, how do I find the value of A? Any point on the graph. Any point of the graph is this one. When x is equal to 0, my y is 7. 0 and 7. So I'm going to say y is 7a into 0 plus 2 squared minus 1. And then when you solve your mathematics and get the value of A, is going to be, what is this? A multiplied by 4, which is 4a. Then with this one, when it goes to that, it's going to be 8, and then A is equal to 2. Okay. And does it make sense that A is equal to 2? Yes. A is greater than 0. Then am I expecting a happy face? Is it happy face? Yes. Okay. Therefore, my equation, it is y is equal to 2 into x plus what? Plus 2 squared minus 1. This is my equation. Okay, yes. And number B, cross that out for number B. I'm having a turning point. Am I having a turning point? Yes. Sorry, the coordinate of my turning point, it is 3 and 0. Again, then I'm going to say y is equal to, okay, let's write the standard form, the turning point form first. Again, and then y is equal to a into x. What is this? This is positive 2. So positive 3. When it goes to my equation, it's going to be negative 3 squared plus, what is my y? Can you see that here? My y, it is 0. I'm generally going to say plus 0. Okay? This is me just substituting. And then I need to find the value of A. So I need to substitute any point. Okay? So this is my x, this is my y. It's going to be 2. It is equal to A into 5 minus 3 squared. Okay, plus 0. I don't need to write it. And then here I will have A is equal to, for A, actually 2 is equal to 5 minus 3 squared. It is 4 for A. And then A, I will get it as half. Therefore, my equation, it is y is equal to 1 over 2 into what? X plus minus 3 squared. How beautiful is that? And then the last one, before we close off, and then come in the next video. Already the video is long. So on this one, we'll just be quick. Okay. Remember this point, it is the turning point here. It is how much? It is the value of x, it is 0, and then the value of y, it is 4. And then here, the coordinate there, okay, let me write the coordinate here. When x is 2, okay, let me write it here. When x is 2, y is 0. So this is any point. This is the what? The turning point. So I need my turning point formula. Y is equal to a into x plus p squared plus q. Y is equal to a. What is my turning point? X plus. It is 0 here. So it will be just x. Okay, let me just say x plus 0 squared plus q. What is my q? My q, it is 4. Okay, my q, it is 4. Then I'm going to have something like, okay, then I need any point. I substitute any point. Any point, it is y is 0, a, and then here I have 2 squared plus 4. Again, then a, and also here a is greater than 0 again, so it is happy like that. And then when I solve for a here, it's going to be for a is equal to -4, then a is equal to -1. And then my equation will be y is equal to, can you see that it is negative? But can you see here, x plus 0, it is x squared. So it is x squared plus what? Plus 4. And this should make sense because it is the normal grade 10 one. Okay. Then the value of a, it is negative. If the value of a is less than 0, and then it is set. Is it set? Yes. So that's all from me on this video. Let's look at the next video where we'll be looking at how to determine the turning point using the standard form and completing the square. Okay, I do not want to make this video long. Okay, but yeah, I hope you understood all so far, and then let's meet on the next video where we'll discuss more. Thank you very much.